In this video, we're going to be talking about ratios, rates, and proportions. A ratio is a comparison of two quantities by division. So it's comparing A to B or A over B, where B is not equal to 0, because you can't divide by 0. Let's take a look at this problem. The ratio of the number of bones of the human skull to the number of bones in the ear is 11 to 3. There are 22 bones in the skull. How many bones are in the ear? So, let's take a look. We've got a ratio of 11 to 3, which we can write as 11 over 3. This is the ratio of the number of bones in the skull to the number of bones in the ear. Okay? Now, it tells you that there are 22 bones in the skull. So 22 bones are in the skull. We want to know how many bones are there in the ear. Well, how could we get 22 over some number equal to 11 over 3? Well, think of it. We multiply 11 by 2 to get 22. So we'd have to multiply 3 by 2 to get 6, the number of bones in the ear. So there are 6 bones in the ear. Okay, so that's how we look at proportions or ratios. In this case, they need to be equal to each other. This one's a reduced form of the ratio. 22 over 6 is not reduced. A rate, a ratio of two quantities with different units. And a unit rate is a rate with a second quantity of 1 unit. We see unit rates all the time when we're talking about miles per gallon, when we're talking about traveling in miles per hour. Those are all unit rates. Let's look at this problem. Ralph Lane of Germany flipped a pancake 416 times in 120 seconds to set the world record. Find the unit rate and round your answer to the nearest hundredth. So, he flipped this pancake 416 times, in 120 seconds. So we're setting this up in fraction form. And now what we're going to do, to get the unit rate, you just divide your numerator by your denominator. So we had 416 divided by 120. And that gives us 3.46 with a 6 repeating. And it says to round to the nearest hundredth, so we will round it to 3.47. And now we're going to write our units as times per second. So he flipped that pancake 3.47 times per second. And this is what you do when you find a unit rate. You just divide your numerator by your denominator and put the appropriate units, using the word per in between. Notice when we said miles per gallon is a unit rate and miles per hour is a unit rate, the word per there between the two units. Let's look at this next problem. Serena ran a race at a rate of 10 kilometers per hour. What was her speed in kilometers per minute? Round your answer to the nearest hundredth. So let's think about it. She ran her race at 10 kilometers per hour for 1 hour. All right. Now we want to know how many kilometers she ran per minute. Well, let's think about that. Well, she ran 10 kilometers, but how many minutes are in an hour? Well, that's 60 minutes. So 10 kilometers in 60 minutes. Now, we want to write our answer as a unit rate. So we're going to divide our numerator by our denominator, 10 divided by 60, which gives us 0.16 with the 6 repeating. So we'll round that to the nearest hundredth, and we'll say it's 0.17 kilometers per minute. Let's move on. A cheetah can run at a rate of 60 miles per hour in short bursts. What is this speed in feet per minute? One of the first things we need to do is set this up as a rate. So we're going to have 60 miles in 1 hour. That's the rate that the cheetah can run. Now we need to change this rate into feet per minute. So how many feet are in a mile? Well, that's 5,280. So we're going to have to multiply. I'm just going to write that up here. 5,280 feet in 1 mile. So to find out how many feet are in 60 miles, we're going to say 60 times 5,280, and we get 316,800 feet. And how many minutes are in an hour? Well, 60. So we have 60 minutes. And now we want to find the unit rate. So we're going to say 316,800 divided by 60, which gives us 5,280 feet per minute. And that is how fast a cheetah can run in short bursts. Now, we want to solve these proportions. We want to find, this is just like solving an equation, same thing as solving an equation, same idea. These are equations, in fact, but they are set up as proportions, where you've got ratios set equal to each other. That's what a proportion is. And how we solve them is we cross multiply. So always remember that's how we start off solving a proportion. So let's go ahead and do that. You've probably done this before at some point. So we're going to say 3 times n is 3n, and 9 times 5 is 45, and we set them equal to each other. We want to solve for n, so divide each side by 3, and n is 15. Let's continue with the next proportion. We want to cross multiply. So we have 6 times 7, which is 42. And we want to say 2 times y minus 3. Now the thing is, we're going to have to put y minus 3 in parentheses because we're multiplying that entire expression by 2. Now, because it's in parentheses, we're going to use our distributive property of 2 times y gives you 2y. 2 times negative 3 is negative 6. And all of that equals 42. Now we have an equation to solve, so we're just going to add 6 to both sides. So we have 48 equals 2y. Divide everything by 2, and we have y equals 24. Let's continue. We have negative 5 over 2 equals y over 8. We'll cross multiply. Negative 5 times 8 is negative 40, and 2 times y is 2y. We want to get y alone, so we'll divide each side by 2, and we get that y equals negative 20. Next problem. A contractor has a blueprint for a house drawn to the scale of 1 inch to 3 feet. This is a very good example of where you see ratios used, ratios and proportions and rates. A wall on the blueprint is 6.5 inches long. How long is the actual wall? Let's think about it. We know that the blueprint scale is 1 inch to 3 feet. Now, we're going to make a proportion where we've got the same units. Inches need to be across from inches, and feet need to be across from feet. We've seen that before when we've been doing our unit rates. The same units have to be across from each other. The wall on the blueprint is 6.5 inches long, so we're going to put 6.5 next to the inches. We need to find how long the actual wall is, which is measured in feet. So this is our x, this is our unknown, and now we're going to solve it. We're going to cross multiply, so we have 1 times x, which is just 1x or x, and now we're going to say 3 times 6.5, which gives us 19.5 feet, 19.5 feet. So that's how long the real wall is, and in the blueprint, it's 6.5 inches long. Let's do this next one. One wall of the house will be 12 feet long when it is built. How long is the wall on the blueprint? Now this is going to be of particular interest to the architect who is creating this blueprint. Remember, our scale is 1 inch to 3 feet. Again, we're going to set up a proportion, inches across from inches, feet across from feet. We know that the actual wall is 12 feet long. We want to know how big to make it in the blueprint. Our unknown is x. That's going to be where the inches are. We're going to go ahead and cross multiply. 1 times 12 gives us 12. 3 times x is 3x. Solve it by dividing each side by 3. The 3's cancel, and we get x is 4. So in the blueprint, the wall will be 4 inches long. That is it for today. Thank you very much for joining.